don't think people know that within this newfound field of generative AI, there's something happening underneath, and that's the philosophical or ideological understanding of how these things work. And I ran across this thought leadership article from AWS AI Science. Do large language models understand the world? And at first glance, you're like, no, there's no way. If you know anything about how machine learning, generative AI, any of these things work, it's with probability and statistics. That the way a sentence is structured is just based on the more than likely this word comes after the preceding word. But is that also how our brains work? Is that how the human mind works? And it's related to this article, AWS AI Labs, and then the person from UCLA. We propose to extract meaning representations from autoregressive language models by considering the distribution of all possible trajectories extending an input text. Just going back here, we empirically show that the representations obtained from large models align well with human annotations, outperform other zero-shot and prompt-free methods on semantic similarity tasks, and can be used to solve more complex entailment and containment tasks that standard embeddings cannot handle. And what we're getting at is there's this back and forth between the understanding of different models within AI, like for neural networks, for example. There's this emerging field, I think it was coined by someone from NYU, called neural systems understanding. And it's this hybrid field of neuroscience and computer science. If we understand more about the brain, can we further evolve and understand more about neural networks? If we further evolve and understand neural networks, can we have a more in-depth understanding of the brain? Same for large language models. Can we improve the contextual outputs, the semantic relationships, get these things to actually have better logic and reasoning skills, understand sarcasm, if we further understand how they understand? And do they understand the word meaning? Because if we look at the definition of meaning, the one thing it tends to convey, especially by language, the thing that is conveyed especially by language, two definitions, something meant or intended. So when large language models are speaking, do they understand meaning? Is their ability through, and I don't know if you've ever seen this, vector space. This is, if you ever heard vector databases and the storage of it, this is the vectorization of different words put within this multi-dimensional space. I think this one says a 300-dimension vector representation. And when you ask a question, for example, in some large language models, it's using things like cosine similarity or Euclidean distance to figure out what is going to be the right answer based on the inputted prompt. There's also distribution meaning, where there's probability of suspected outputs. And you can look at this example here, and that's more closer aligned to how things like a generative pre-trained transformer like GPT OpenAI model, but they actually use kind of a hybrid model. So through the vectorization, they're mapping out contextual meaning based on your input, and then using something like a distribution to find the right word or token with more probability than not of what the sentence structure should be, if that makes sense. So is that how our brain works? That's kind of where we're going with this more philosophical question about probability space and understanding how large language models are working. When you're asked a question, is there something innate or we're doing unknowingly, this massive amounts of calculation in this organic matter in our skull that is allowing us to understand what the right output is in response to someone's prompt, someone's question? Is that how our brain works? If you ask me, is the sky blue? Yes. Immediate reaction, yes. But I've learned that. I'm training it. Probability is more likely than not that you're not being sarcastic, so it's not going to require me to make a sarcastic response. Well, sometimes it's gray. I got a window right here, and if it's rainy out, technically the sky's always blue, but clouds are going to be gray. But that's besides the point. Based on me doing some internal calculations, is that the right response for you? And that's, if we can kind of understand that, is there a next evolution of the proper way to attribute meanings to words for LLMs to have better improved output, building upon them. I think there's further in conclusion here. If the model and human have been exposed to similar data, however, and if they have shared enough experiences, then there's a basis on which to communicate. Alignment can then be seen as the process of translating between the model's emergent inner language, we call it neuralese, and natural language. How faithful can the alignment be? Let's see. In one form or another, questions about the relationship between the world and its representation have been central to philosophy for at least 400 years, and no definitive answers have emerged. As we move toward a future in which LLMs are likely to play a larger and larger role, we should not dismiss ideas based on our intuitions, but only continue to ask these difficult questions. The apparent limitations of LLMs might be only a reflection of our poor understanding of what meaning actually is. It's pretty cool. Thoughts kind of go everywhere when you're talking about something like this, and there's no right or wrong answer. Some people will just flat out say, no, it's a computer. That things like, here, this is a notebook that I have, a Jupyter notebook of this fun little Shakespearean GPT that I did a project on, where you input Shakespearean works through just simple text, and then you encode it. And this is how a computer sees it. It vectorizes it. It turns it into a bunch of numbers that are correlated into all of these random, where is it at? These random characters that you can see here. And then through a bunch of linear algebra and a whole bunch of math, you can go all the way down here, and you can train it and you can generate an input. Is there meaning? Is there meaning behind the output that is trained into it based on how I created this GPT model? I don't know. But it's interesting. It's something to continually look into as we start going down the path of the black box of these things that are being created. We got to have an understanding of how these things are working, because we want to reel them in, rein in any sort of dangers, any sort of ethical things that are going to happen. And also, what's that next evolution? How do we think outside the box? How do we make these things evolve? How do we think of other ways besides distribution meanings or vectorization and correlation and probabilities to get these things smarter and more useful? Let's talk about it.